Son, what are you doing?
I'm Iron Man.
But son, you know that Iron Man's not real, right?
What?
Remember, son, that the Iron Man that you know and love on your television is simply two men running around in their pajamas with stickers on their chests so that they can be digitally enhanced with CGI. So your beloved Iron Man is not real. But remember, son, he could be.
Really? But how?
Well, son, let me tell you that real Iron Man made out of iron is highly unlikely.
What?
But if we made him out of carbon nanotubes...
What's a carbon nanotube?
Boy, let me tell you!
Oh, okay.
A carbon nanotube is simply a cylinder of varying width that is composed completely of carbon molecules. Each molecule is bonded to three other molecules that are connected with a single bond and a delocalized pi bond. This pi bond allows for conductivity of energy, which you would only find in things like metals. And carbon is not a metal. And though the technology is still fresh, this kind of conductivity would allow Iron Man to do things like shoot light from his hands and have all of the circuitry in his suit be there without wires. This is due to the sea of electrons that carbon nanotubes possess that are normally found in metallic bonds as well. This sea comes from the free resonating electrons that are pushed by the charge of other electrons in the form of a wave or a current. So what that means for you, son, is that Iron Man could be able to do this.
Really?
Well, it'd look more like this, but let me tell you how strong carbon nanotubes are. Carbon nanotubes are essentially sheets of graphene rolled up into a cylinder shape. And in principle, that cylinder shape is just naturally stronger. For instance, if you take a piece of paper, roll it up, and then stack books on it, that piece of paper would be able to withstand far much more than its flat counterpart. So if one toilet paper roll can hold almost 20 pounds, then think about what graphene, something that is normally over 100 times stronger than steel, could withstand. And that's just a single tube. Carbon nanotubes are small enough that they can be woven into many different intricate shapes, so that these fibers can withstand all sorts of different strengths. And did I mention that it's extremely lightweight too? These woven fibers allow for Iron Man to have armor that's strong enough to be bullet resistant, yet lightweight enough for him to fly. But then again, that assumes that he has his propulsion system as well. No, that's not all. Carbon nanotubes are also very thermally stable, which means that this suit would not heat up as bad as you see in the movies. This is because his heat energy would be transferred out just as easily as electrical energy flows through the carbon nanotubes. Also, carbon nanotubes are thin and small enough that they could easily pierce the skin or even a cell wall and be able to inject poison into all of Iron Man's enemies. But just keep in mind that nanotechnology is still very new. But, based on the fundamentals of what we know about carbon nanotubes, this would allow for any single person to be able to control their own suit by having needles injected into their spinal cord and then having the electrical impulses from their brain control the suit. This is the same kind of technology that we see from Spider-Man's enemy Doc Ock. So not only does this open up the opportunity for Iron Man to be real, it also would make him even better. These kinds of things could make it so that Iron Man could simply punch someone and they would fall asleep because of the anesthetic that he injected. Why yes, there are other uses for carbon nanotubes besides simply making Iron Man real. First of all, nanotubes could be used in the medical field for making things like painless needles a reality. This would be possible through their very small size and conductive properties. Since carbon nanotubes are hollow and they can be made with varying diameters, you can easily pass chemicals straight through them into your body. Research from Monash University shows that these free electrons also allows carbon nanotubes to be really good radio transmitters. So what that means for you is that that cell phone in your pocket could be even smaller and more efficient. Or you could have a tracking device put inside you. Sadly, there are some downsides to carbon nanotubes. The first and most obvious of which is that most of our research is still young, and due to this, we don't know some of the dangers and defects of carbon nanotubes. For them to be completely useful in the medical world, we would have to know exactly how people react to them and if anybody is allergic to carbon nanotubes. Another problem being observed in carbon nanotubes is that during synthesis, sometimes there are deletions which can compromise the strength of the nanotube. Another issue with carbon nanotubes is that they are difficult to make consistently and become more expensive with a greater yield. So laser ablation may produce more than arc discharge, but it is at a way higher cost. So what this means in a nutshell is that you would have to be Tony Stark with his whole industry behind him to be able to adequately prosper with carbon nanotubes and be able to make something like his suit. So in a nutshell, due to carbon nanotubes' strength and metallic-like properties, Iron Man could be real, as the carbon nanotubes could make up his suit, his electrical system, and even his little blasters. And with some of the new projected technology, he could even have better weapons than he does right now. However, it is good to keep in mind that nanotechnology is still being researched, and it is very expensive and very inconsistent to create carbon nanotubes as we are doing today. So Iron Man could be real during your lifetime, but definitely not while you're still a kid. Also, carbon nanotubes could be making an appearance in your local hospitals anytime soon, due to their projected uses and abilities.
So, with a little bit of ingenuity and a lot of this, Iron Man could be real.
I don't want to be Iron Man anymore. I want to be Carbon Nanotube Man.